Hello and welcome. Today we are going to have a look at the string buffer class in Java. In order to understand why the string buffer class is important from the perspective of Java, we need to first of all see what were the limitations of the normal string class. In order to understand that, we are going to write a small program and see the various aspects of it, okay? So let's create the main method. And let's create a string. Yeah. So in this string, let us see what happens in memory. So we all know that because we have used this kind of initialization, there will be a string pool and there will be the string within a particular location inside the string pool, and S is going to point to this location. Alright, that is what this does. And well, it is not really specific to the string pool or something. Even if you would have done it in this way, it is going to be okay for all of these things that I'm going to say afterwards regarding the string class. It's not really going to make a difference whether or not you use this kind of initialization or this kind of initialization for the purposes of understanding the importance of the string buffer class. Alright? Now, so you have this string toy and you have S, which is pointing to the memory location in the string pool that contains toy. Okay? Now what happens, say suppose, if you want to make a change at this second character. You want not toy, but maybe tay, T-A-Y, anything. I mean, it need not make sense. But yes, say suppose you want to change this O to A. Is it possible with this string class, with this predefined string class? Well, as it turns out, strings are immutable in Java. This is a very important thing to keep in mind. Strings cannot be changed. Once you have created this string, it points to a memory location TOY. It is going to point to that memory location and you cannot make any change to that memory location in itself. That is, if you want to suddenly change the contents of this memory location to something else, okay, that is not allowed by the string class. That is just not allowed. Instead, what you will have to do, if you want to make some minor changes such as changing toys O to A, what you have to do inevitably is create a new string, okay, as TAY. Somehow you have to create a new string as TAY, and then you have to basically reassign S to point to the memory location of this newly created string. Alright, now how we create this string is completely specific to us. We can simply understand what we need and make it TAY. Okay, this can be done. So in this case also we have changed the second letter from O to A, or we can also use a very general approach such that we can make S dot substring from 0 to 1. Then this character can be changed to A. Then we can again take the substring as 2 to 3. Okay, and then we can print this out, and this should in fact give us tay in place of toy. Oh yeah, well, okay, it should be substring and not substring. Yeah, so we see TAY, so we have successfully changed the second character. But as you can see, in order to make this change, we had to essentially create a new string. Okay, we could not do it in place. This is a new string which has TAY as its contents. Alright, this is what has happened in this case. So let's say, suppose, let me show you another example where the normal string class in Java is pretty bad. Okay. So let's say you have the string. Okay. And now you want to append a character to it. Again, you cannot do it in place. So what this is going to do is, since strings are immutable, it is going to take this as an expression and return a new string which has TREA. Okay, TREA, or let's just make it E. Yeah, that should make more sense. Okay. It is going to return a new string which has TRE followed by a E. And what we do is we make S point to the newly created string again. Okay, this is what it was previously pointing to. We create the new string as TRE and make S point to this newly created string object. So again, let's do system.out.println S. See, so we have successfully created tree. But this was a 3-letter string. Say suppose you had a 200-letter string. So in that case, when you execute this statement, what you would have to do is copy all of the 200 characters again and then append another character at the end. So in the case of very long strings, this concatenation turns out to be pretty bad in terms of time complexity, isn't it? It's a linear time complexity algorithm, whatever is going on here. It's completely linear. It's not good for something as simple as concatenation. And to be frank, concatenation to strings should be something that, will be required more often than not. So in order to address these two issues, that is changing a string in place and also concatenating strings, we have what is known as the string buffer class in Java. So the string buffer class, let me just show you something. Yes. We shall go into more detail later on, but let me just show you a slight functionality of it just to get you more interested. Println SB. Let's compile. Yeah, let's compile the program. Yes, so we have A, B, C here. So as you see already right off the bat that this guy supports append operations. Okay, that was not being supported in the last case. In the last case, what was happening is that you were actually creating a different string. You're creating a different string and changing its location to this. But we shall see later on how this append works. But you can assume that for most of the append operations, again, we shall go into details later on, but you can assume for the most part that when you run this append operation, what happens is that internally Java has created a character array, okay, a pretty long character array, and the string that you already have, which was in this case TRE, occupies only a small portion of that array. Okay, and all of these locations are ready for use. So when you make an append operation, okay, when you call this append member of this SB object, what you do is you just put the additional character over here. Or you can also put a string. Actually I've put a string here, but it consists of one character. So whatever. Okay, so this is how. Whenever you append something, this is what happens. It just gets put into this array over here. Now what happens when, say suppose you have reached the end of the array. So like you have made many insertions. You have taken up this space, this space, this space, this space, and this. Now what happens when this is the case and you want to add another character here? So in this case, you do not have anything over here, right? This is unallocated memory. You cannot access it. Whatever you had created, I mean the array which you had created initially is only this much. So you cannot enter another character into it. So what happens in that case is that when you call this append function again, Java internally reallocates a larger array, okay? And if the length of this previous array was supposed to be L, the length of this array is 2L plus 2. Get it? So say suppose the initial length, initially string buffer had allocated 4 locations, a character array of size 4. Then if you have exhausted this array, it is going to reallocate another array which is of size 2 into 4 plus 2, which is 10. Okay, so in this case, so how long was this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, so it should be 22. Now, that's pretty hard to do though. But yeah, just get it. This is 22. This is of length 22. And this is again going to be, and this whole string which was present, okay, in the last case, remember what we are trying to do is appending at the end of this string which is present in this character array, okay, which is maintained by the string buffer. So if you have exhausted it, this newly created array is this new array is created, and whatever was present before is again copied here, okay, it's copied here. Whatever was present is copied here, and since this is much larger than this, now you have a lot of space left, and you can simply insert the new character that you originally wanted to insert here but could not because of the lack of space. Okay, so let's take another example in this regard. I guess that should clear things up a bit more. So say that the string builder had created an array. So the string buffer class had created an array of just size 2, and you have already populated with A and B. Alright, now you want to enter another character E into this place, but since the array size is 2, you cannot put it into like thin air over here. What Java will do is it is going to make another array of size what? 2 into L plus 2. 2 times L plus 2. And what was L here? It was 2, so it's going to be 2 into 2, 4 plus 2, 6. So it's going to create another array of size 6. It is going to copy this string, and whatever you wanted to insert is going to be put here. And now you've got additional space too, so you can perform further append operations without any need of reallocation. Okay, so this is how the append operation works. So right off the bat, you can feel that this append operation is much more less expensive in comparison to the concatenation operation, because you are not copying down the entire string on every append. You're just doing it sometimes, and as it turns out, if you do it constantly, if you do it repeatedly for a large number of times, the overall time complexity is going to be constant. It's going to be constant. It's called an amortized constant time complexity, but for all practical purposes, you could just consider it as constant time complexity. That is, essentially it's free. It's just the fastest that it could be append operation. Okay. Now let us look at the replace operation of the string buffer class. So let's initialize it with some string, and we were using toy previously, so let's use it again. So replace, let's try to replace this character. So this guy actually takes 3 arguments, which is start, end, and the new string. Okay, so let me tell you what these are. So int start is nothing but the start of this string where you want to make the change. So in this case 0, 1. Int end is nothing but the end, the position in this string up to which you want to make the change. So in this case you want to make change to only one character, so you start at 0, 1 index and make the change up to the 2 index. Okay, and it's non-inclusive actually. This end is non-inclusive, just as in substrings. And let the new string be A. Alright, let's print it out as well. Oh yes, right. I missed the equals operator. That was not good of me. And yeah, as we can see that it's DAY, so we have successfully replaced it. And also you can make some bigger changes. Say suppose you had a bigger string such as say an elephant, okay, and you wanted to make it elephant, or rather let's change this whole thing, okay, PHAN with FAAN. Alright, in order to do that, what we can do is we have to take the start 0, 1, 2, 3, and this is going to be the start. Oh, let's not spoil this up. This is going to be the start, and the end is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8. So 8, and let's make this so we have successfully replaced the string. And what is happening here is that there is no new string created. Okay, there is no new string created. It's pretty simple, pretty intuitive. What's going on is there's no cheating going on. It's simply this array of characters. You can visualize it in this way. It's simply this array of characters, LE, fant. Okay, it's simply this array of characters, and when you give the start and the end, which is 0, 1, 2, 3 up to the end minus 1, it's simply going to replace out all of these contents with f whatever you have given here, which is the new string, which is FAANT. Okay, FAANT. Alright, and so you have the resulting string ELEFAANT, whichever planet that creature belongs to. Okay, so that's there. And yeah, let us see two of the constructors that the string buffer class actually makes use of, and that is pretty important. Not really pretty important because it's internally implemented, but yeah, it's good to know. So one of the constructors is, okay, let me show you two string buffers. That would be much better. sp2 equals new string buffer. Okay, let's give this an integer of 2, and let's give this apple. Okay, now we are going to do something. Let's see what the size what the size of this internal array is. Let us see that. In order to do that, we have a method which is called capacity. Okay, again, let's do this. sp2.capacity. Yes, and here we have it. So what does this method do? See, I told you, when you create a new string buffer, there is an internal array, when you create a new string buffer here, there is also an internal array that belongs to sp2, and the capacity method returns the length of that internal array. Okay, so let's see what is the length when we use this constructor and when we use this constructor. Java C test.java, Java test. Yeah, so see, this integer that we passed here, that is supposed to be the length of the initial string when we use this constructor. Okay, whereas when we use the other constructor, which makes use of a string as its parameter, what happens is the length of the initial internal array is 16 plus the length of the string. It's just that. It's just a random choice made by Java. If there is any reason, I don't really know that. But yes, that's what happens when you provide a string. 1, 2, 3, 4, 5, 16 plus 5, 21. Alright? So this is how two of the constructors work. And also, if you are a bit skeptical as to how this array grows, we can also write a small program to show how it grows. Okay, just for the sake of it, let's see how it grows. sb1 dot capacity. Let me show it to you that it is actually 2l plus 2. I'm not kidding. Yeah, so that's there. I'm going to print out the capacity, sp1 dot capacity, and make the previous capacity equal to this. You can analyze this program if you want to. It's nothing much. And yes, let's append something to it. sp1 dot append a. Yeah, so let's see how it grows. Okay. Oh yeah, we can just remove this one. Let's remove that and recompile and run it. So see, it was 2. 2 into 2 plus 2 is 4. 2 into 6 plus 2 is 14. 2 into 14 plus 2 is 30. 2 into 30 plus 2 is 62. And 126 is equal to 62 into 2 plus 2. So I guess you would have been satisfied by now that this is what happens internally, and I think you should be confident enough. Well, this in no ways is all the functionality that the string buffer class provides. Replace and append are just two of the many functionalities. If you want to look at the other functionalities, you could make use of other sites, such as, like, I personally like Geeks for Geeks. You can take any site of your choice, use the official Java docs, whatever you want, and you can make use of them in order to see what other functionalities are provided by the string buffer class. But yes, this is the core concept of how the string buffer class works. So yeah, see you next time.